This video will cover the material in the second half of Chapter 1 in our textbook, which Chapter 1 dealt with starting or beginning a research project. So in this section, we will look at variables, we'll look at hypotheses. So let's take a look at variables. So a variable or variables are the primary components when we're building a model. And variables are observable characteristics that can have more than one value. So here's an example from your textbook: gender, which could have values of male or female; job satisfaction might be measured on a Likert scale with 4 levels; salary, which is the actual dollar amount; and then age, which would be the number of years since birth. Talking about the components of a model again, a constant is an observable characteristic that doesn't vary, so it's different from a variable. So for instance, researchers will often study only specific cases in a population. For example, females in a study of employee age and preference for team genders, and in this case gender is a constant because we only selected females. A variable in one study can be a constant in another study. So we want to study the relationship between gender, age, and salary, and in this case gender is a variable. But if we focus instead just on the females, now gender becomes a constant. So the context of the problem will tell you whether or not a particular attribute is a variable or a constant. So let's talk about hypotheses. So hypotheses, or a hypothesis, is a statement that specifies or describes the expected relationship generally between two variables in such a way that the relationship can be tested empirically, in other words, by collecting data. Hypotheses form the foundation of a research effort. Clearly written hypothesis helps the researchers decide what data to collect and then how to analyze that data that they have collected. Let's look at some examples of hypotheses. And these are all what we call the research hypothesis, which is the hypothesis that we're trying to support when we run a study or collect the data. So here's one. Persons jailed for burglary are more likely to be rearrested once released than those jailed for assault. So the variables here are the type of crime for which the person is jailed, and then the probability of being arrested again. Here's another example. City governments keep more supplies in storage than do county governments. The variables here would be the type of government, city government, county government, and the amount of supplies. And in these two examples, the hypotheses are fairly reasonably specific. Now, what I might have a little bit of a concern about is in the second hypothesis there, what do we define the supplies to be? Is that all the supplies or particular office supplies? So we might want to be a little bit more specific in that second hypothesis. Third one, training programs improve the skills of the chronically employed. Now, the variables here are a little bit murky. What kind of training programs are we talking about? What does chronically employed mean? Oops, wrong line, sorry. What is meant by skills? So you would want to, in this case, elaborate. Are we talking about particular job skills? Chronically employed, would that be unemployed more than 1 year? You would want to define better, or the data that you collect may not actually let you prove the hypothesis that you're trying to support. The city manager form of government is more common in southern states. In this case, and in a minute we're going to talk about independent and dependent variables, but they've given us a value for the independent, which is the region of the country, and also for the dependent, which is the type of government. Let's try a couple together. We want to identify the variables in each hypothesis. Suicides in jail are more likely to occur during the first 24 hours of incarceration than at other times. So the variables here are going to be the occurrence of suicide in the jails and then the length of incarceration, or is it within the first 24 hours or not? We probably would want to collect the length of incarceration because actually the suicide rate might be higher in the first 48 hours. So we might want to collect a little bit more data than we actually stated in the hypothesis. The lower the turnover in inventoried items, the greater the amount of waste caused by spoilage, obsolescence, or loss. So the variables here are the turnover rate and also the amount of waste. Now, the next one here, training programs improve the quality of the chronically unemployed. It's not easy here to really determine or identify the variables. Again, this is like the example we had before. What kind of training programs? How do we measure the quality? What do we mean by chronically unemployed? And in this case, the model is poorly defined because we really don't know what data to collect or who to collect it from. I mentioned earlier independent and dependent variables. The independent variable is used to explain variation or change in another variable. It's what we call the input or the explanatory variable. Another word you may hear is predictor variable. And then the dependent variable measures the characteristics being explained, and it's the outcome or the output variable or the predicted variable. So let's talk about characteristics of good hypotheses. Now your book says they should include one independent and one dependent variable. That's not always true. It might be optimal, but sometimes we only have one variable in the model. Each variable is clearly stated. We mentioned that before. From the wording, it is clear how each variable varies, and the expected relationship between the variables is clearly defined. And if you remember some of the examples, let's just go back for a minute to a couple of those that we looked at here. Training programs improve. There's the direction of the relationship. The quality of, and that's the dependent, the chronically unemployed. Another thing to think about, what's the unit of analysis when you're going to collect data? So when you're testing a hypothesis, you have to use the same level of unit of analysis at the same level of aggregation as in the hypothesis. The cases or the entities for which we measure the variables are the units of analysis. So for example, in your textbook data set, the unit of analysis there are the counties because the data is collected at the county level, aggregated at the county level. Although some of the data in that data set might come from individual people within the county, it's reported at the aggregate level of the county. So consider this hypothesis. The higher the student's school attendance record, or the better rather, the higher the student will score on the SAT exam. That's a reasonable hypothesis. It's just specifying the variables and the direction. And the units of analysis here in this hypothesis are specified as the individual students. But the researcher doesn't have data on individual students, but she does have data from a large number of school districts. So the researcher tested that hypothesis and found, using that data, that the average SAT scores of students from districts with higher average student attendance, the SATs are higher than the SATs from the districts with lower attendance. Now notice, this is a different hypothesis. It's not the one we actually stated. We can't conclude, based on what we tested, that we can say this is true at the student level. We can say it's true at the school level, but not at the student level, because the unit of analysis in the data that we used down here is different than what was specified in the hypothesis. So you want to think about this. You want to actually determine your source of your data to make sure it's going to be aggregated at the level at which you write the hypothesis. Okay, the nature of relationships that we might see. Important characteristic we mentioned before in the hypothesis is that it specifies the pattern of the relationship. So in the one we just did, we said the better the attendance record, the better the SAT scores would be. And covariation is the patterned relationship between an independent and a dependent variable. And the forms that we can see are positive or direct. For instance, in the attendance and the SAT scores, that would be a positive or a direct. As the attendance goes up, the SAT goes up. Negative or inverse, as unemployment rate goes down, median family income goes up. Nonlinear, I'm going to show you an example of that in a minute. It doesn't follow the same pattern as we move through increasing the independent variable. And then random or null. And let's take a look at what these graphically look like. On the top left, you see a positive relationship. So here, as x is increasing, as the independent variable is increasing, the dependent variable is increasing. Here's a negative. That was where I said, as the actually in this case, if you put the unemployment rate on the x-axis, as the unemployment rate increases, what happens to the median family income? It goes down. Nonlinear. Starts here, goes up, and then goes back down. Or it could start high, go low, and then come back up. And then this is what we call a random or a null pattern. There's no pattern in here. As x is increasing, we can't generally say y is increasing, decreasing, or have a nonlinear relationship. So a control or a confounding variable is a variable that's related to both the independent and the dependent variable. And this helps us to identify spurious relationships between variables. Here's an example. Arrests for assaults increase with ice cream sales. Now this is a spurious relationship. There's no reason for arrests for records to increase when ice cream sales go up. So we start to think about a control or a confounding variable. So if we examine, for instance, the effect of the average daily temperature as the control variable, we'll find that hot weather may actually explain the increase in the assault arrests rather than the ice cream sales. Common control variables include age, sex, income, education, race. A moderating variable, in addition to helping identify a spurious relationship, control variables may also alter the hypothesized direction dramatically. And these control variables are called moderating variables. They moderate or they change the relationship between the original variables. And we're going to take an example that's in your book, example 1.3. And the problem was to identify successful job training programs for hard-to-place individuals. And the hypothesis was that on-the-job training would be the most successful than any other training programs in placing participants. The independent variable is going to be the type of training program. The dependent is going to be whether or not the person was placed in a job. And the control variable here is going to be the education level of the person as they come into the training program. So here's the first overall. We're not going to include the control variable right now. We're just going to look at the overall success. So the vocational had an overall success of 31%, on-the-job training 41%, work skills 23%. So right here it looks like the on-the-job training seems to be the best and the work skills seems to be the worst. Now let's break that same set of data down by the control variable, which is the education level of the person. So less than high school graduate, or more than high school graduate, some college. Now if we look at the data, when the education level is controlled and held constant, vocational and OJD do about the same for the non-high school graduates. The other groups seem to do better with on-the-job training. And notice work skills doesn't do well anywhere. But we get a different look at the data when we see this broken down by the control variable. So it sometimes helps us to better understand the relationships that we're observing in the data that we collect. The last section in this book talks about selecting a research question and looking at it from the perspective of students, analysts, and administrators. So students, you as a student in public policy, have the most freedom in selecting a topic. You're not going to make a programmatic decision based on a research problem that you do, probably, unless you're in a internship or co-op, but you should be interested in the topic. You must have or be able to develop the required knowledge and skills, and then have sufficient time and resources. The analysts, those topics are going to be relevant to the decision at hand. They must have the required knowledge and skills, and that knowledge can be supplemented by co-workers, contractors, etc., other experts, what we would call experts in the field. And then finally, the administrator, this is like the supervisor or the program manager, they use the research findings to identify problems, evaluate solutions, make decisions. They often rely on knowledge, research skills of others, and they should be sufficiently engaged to oversee the project and to question the research strategy and its findings. They may not be involved in every step of the process, but they should be knowledgeable enough so that they can oversee it and also question, especially if the findings are not what one would have expected. So this is the finish of Chapter 1, and again, quantitative research requires investigators to articulate the purpose of the study. We talked about elements and relationships, the preliminary model. The elements are generally variables, control variables might be used, and literature review, which we talked about last week, is a critical source of information.